This PowerPoint is designed to help you revise how to draw atoms using the information from the periodic table. So here are the basics of what's in an atom. You've got protons and neutrons. They're both found in the nucleus of the atom, which is the centre of the atom here. Okay. Protons have got a charge of +1. They've got a mass of 1. So the mass is relative to the same mass of the neutrons. Electrons are found in the shells surrounding the nucleus. They've got a negative charge, -1 each, and their mass is so small that it's classed as negligible. Okay, so we don't add that into the atom when we look at the total mass of the atom. So we can use the information from the periodic table to tell us how many protons, neutrons, and electrons an atom has. The smaller of the two numbers in the box of the periodic table tells us the number of protons. The number of protons in an atom is also equal to the number of electrons. That's because protons have got a positive charge. Remember, protons are positive, and the electrons have got a negative charge. So for overall the atom to have 0 charge, then the number of protons must equal the number of electrons. The larger of the two numbers is the mass number. This is equivalent to the number of protons plus the number of neutrons. We don't add in the number of electrons because remember they've got a negligible mass. They've got in effect 0 mass. So if we were trying to work out the number of neutrons, we would subtract the number of protons, the bottom number, from the total mass, the top number. So for this example, we've got 11 protons, we've got 12 neutrons, 23 minus 11, and we've got 11 electrons equal to the number of protons. See if you can answer these questions. Pause and then listen to my explanation. So the answer to question 1, why isn't the number of electrons added into the overall mass of the atom? It's because it's got a negligible mass. It's near enough 0 to be classed as 0 when we're looking at the total mass of the atom. And why does the number of protons equal the number of neutrons then? This is to do with the charges. Protons have got a positive charge, or 1 plus charge per proton. Electrons have got a 1 minus charge per proton, and so the two of them will cancel out their charges if the number of protons and electrons are equal. And overall an atom has 0 charge, so the numbers of those do have to be equal. Okay, so try some of these now yourself. Pause the video, fill in the information, and then have a look once you've filled it in. So these are the answers. Hopefully you've been able to do that without too much difficulty. Okay, so what about drawing an atom then? Well, an atom consists, as we've seen before, of a nucleus, so that's this central area. I tend to shade that in just to show that it's not one of the shells, followed by a series of rings, so starting from the inside, which are known as shells. This is where we're going to put our electrons. Now you do need to remember how many electrons each shell can fit into them. Okay, so the first shell, which is the one closest to the nucleus, can contain up to 2 electrons. The second shell, up to 8 electrons. The third shell, up to 8 electrons also. And then the fourth shell, up to 18 electrons. You won't be asked for anything bigger than that. So here's the first example. Here we've got sodium, the example that we looked at before. We know that it's got 11 protons, which means it's got 11 electrons, and it's got 12 neutrons. The protons and neutrons are in the nucleus there. Not really interested in that at this moment in time. What I am interested in is how the electrons go into the shells. So the first shell is going to contain 2 electrons. So we put them both together because there's one what we call suborbital or subshell. So that's one area where they can exist. So the first one goes in, the second one has to go into the same place. So the next shell, the way that I teach this is to fill them up top, bottom, side, side. So that's your first 4, and then they're forced to double up after that. The second shell has got 4 subshells or 4 suborbitals where the electrons can go. So just rewind that back a second. If you've only got 1 electron, it goes into the first subshell. The second one will go into the second subshell, which is as far away from the first one as possible. Then the third, then the fourth. At this point, you're then forced to double up. Okay, so then they will double up. They won't double up until you've got 5 electrons in that shell, because the electrons have got a negative charge, so they will repel each other. So they'll go into the 4 areas first before they're forced to double up. Okay, so the next shell, we've now got 1 electron left, so that's where it's going to go, into the third shell, which means we didn't need to draw the 4th shell, so that one disappears. We can write this as an electronic configuration as 2, 8, 1, so you can either have it drawn or written. So you try these, pause the video, try to draw them out, and then have a look at the answers once you've drawn all of the atoms out. Okay, so here are the answers. Don't really like this one in terms of the 2 electrons here should be together, but it's not overly important. And then there's 1 electron on the next shell, which is correct, so 3 in total. Aluminium, 2 on the first shell, again, I prefer if those 2 were together. Then 8 on the next shell in the 4 areas, and then 3 on the outer shell. Hydrogen is just 1 electron, so that's on the inner shell. And then calcium with the 20 electrons, we've got 2 in the first, then 8, and then 2 in the outer shell.